So I took off the two other CVRs and put on 4 parallel 1 ohm resistors, just like you know who, and and I got rid of the extraneous circuit elements and put some nice clips on there so I could disconnect things. So now I want to show the effect of adding a little bit of series inductance to the negative lead to the battery here. So right now we got the function generator drive going. Let's see where the zeros are. The scope might still be warming up, so I'm going to turn the channels off, and yeah, I need a little bit of adjustment. So there's 0, and there's 0. Okay, so now we have function generator drive and common gate signal. You can see it's sitting up there at the battery voltage, and there's little things there. So if I vary the gate drive as usual, we don't get oscillations much. We get those little spikes in there, but that's at 20 volts per division, by the way. So I blow it up a little bit more. So I'm going to go ahead and put this on AC coupling for a moment because I want to emphasize the oscillations. Alright, so now we're not going to be sitting up at the battery voltage anymore. We're just looking at the relative signal, which is what's going on in here. So this is no longer the baseline voltage over here because I'm AC coupled now. Okay, see there, AC coupled. All right. So now I've got the ground terminal or negative supply lead to the TarBaby connected directly to the battery, and that's our voltage. And so you can see the spikes there, but as I vary the function generator drive, you see no characteristic oscillations. Now what I'm going to do is just take the negative battery lead here and go down this chain of inductors. It's a little chain of those little brown inductors, so I'll be going one at a time, 2, 3, like that. Okay, so we already saw it with no inductor in, so now I'm going to put 1 in, like that, and then we'll tweak the gate drive a little, and see, there's a region there where we get some nice oscillations by tweaking the gate drive. See, oscillations. All right. So now I'm going to go to the second inductor in the chain, like that. So now we're looking at 2 inductors, and look at what happens. More magnitude on those oscillations. I'll disconnect it for a moment and go back to the first one. Oh, sorry, first one. There, okay. And none. So that's 0, 1 brown inductor, 2 brown inductors. Shall we go for 3? 3 brown inductors. Caught in my clips here. Sorry. 4 brown inductors. 5 brown inductors. 6 brown inductors. Starting to see a pattern here. The oscillations, which are feedback oscillations, are very sensitive to the amount of inductance that you have in the circuit. This just represents some wire length. These are not very big inductors. They're in the microhenry range. So that's just some extra wire length. That's all that is. And you can see the profound effect that they have on those feedback oscillations. Here I'm tweaking the function generator drive a little bit again. See the nice stuff happening there. MOSFETs are actually switching. And there's oscillations. Okay, let me go back to DC coupling there. So now, since we're at 10 volts per division, we're sitting way up above the battery voltage, or rather way up above the baseline on that oscillation. So now let me go to 50 volts per division like we have been looking, and there you go. There's the battery voltage and then the oscillations on the drain trace. And there's varying the function generator drive. That's all a result of the little added inductance in the leads to the battery supply. Thanks for watching.